Are we... Mic check 1, 2. All right. Hello, friends. So, welcome back to another of these AI dev streams. This one actually live, so testing that out for a bit. Apologies if I missed chat or any of that good stuff. This is the first time doing this legitimately live. But anyway, so what we're going to be having a look at today is Stable Diffusion. If you've been hanging around in the AI world recently, you're probably familiar with Stable Diffusion. I wanted to take a look at it from the perspective of somebody who's done a lot of work in AI and has been in AI for a long time. Have a bit of fun with it, but also, talk through it from an AI perspective, look at some of its shortcomings, and I'll probably clip this into a shorter video down the line. But anyway, we've got about 90 minutes in which I will be playing around with this. We'll test both text to image and image to image and play with a bunch of the settings, test some ideas around prompts, etc. But without further delay, let's switch over to this setup and dive right in. So what you can see here is a web UI built on top of the Stable Diffusion library. The Stable Diffusion release that I'm using is just the standard one that they released, waits off Hugging Face, but somebody's built this web UI. I will pop a link to the setup instructions for this in the video description after I finish streaming, so you can check that out and have a go. In terms of the machine that this is running on, this is on one of my local machines. It has a 3080 Ti. It has 64 gig of on-device RAM and a 3-point-something gigahertz processor. So, not too bad a system, but nothing top of the line beyond what somebody who plays a few games or does a bit of AI on their own might have. So, quick description of what you might be seeing. You've obviously got the web UI here. I've got my terminal here. This is mainly just so you can keep an eye on how quickly these images are being generated. If we do run into any bugs, you can have a look at those. But without further ado, let's dive straight into this. So you can see here we've got the prompt entry point where we can put in our prompt and it'll start generating an image. We can change the image size. For the most part, we'll probably leave that as it is because that's about as big as you can go without running out of RAM. We'll try a few smaller images because there's some points I want to make there. And a number of other parameters down the side here, all of which we'll play around with. We will actually right now just put up this batch. Oh boy, not that high. What that'll do is it'll generate multiple images per prompt and we can have a look at the difference here. This will generate them sequentially rather than in parallel. So in parallel, you naturally use a bit more RAM because you've got a bigger batch size. This will just do the generation 3 times and put them up on the screen. But from my testing, it's fast enough that it really doesn't matter. On this side, we've got sampling steps. We've got different sampling methods. You can see if you play around with this, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different sampling methods. You can't see the pop-up, but doesn't matter. We'll test a few of those. We've also got some advanced options here around how we can combine prompts to test a few different ideas. Some other things around whether we save the images and everything else. Variations and some seeds. The other thing that we have here is also the image-to-image mode. So we'll try and spend most of our time on text-to-image and then spend a bit of time on image-to-image as well. Anyway, let's get started. So to give you an example, we'll use the prompt that they use as the hint here, which is a corgi wearing a top hat as an oil painting. Now, if this doesn't work, then I'm going to be very embarrassed and we're going to have to do some live debugging, but from my tests, last time it worked. All right, so you can see there it's kicking off some image generation. So on my machine, it takes about 4 seconds to generate one image with the 50 sampling steps, which means it's about 12, 15 seconds with a little bit in between to go through these. So you can see here what it's done. As we said, it generated 3 images and it's put them into this little grid, which we can see here. and it's also gone through them one by one. So you can see, for things like this, obviously it's the default prompt. It does an okay job. I don't know what an oil painting of a corgi with the top hat would look like, but this would be a possible example, I would say. The hat here doesn't really look like a top hat. Looks more like, are they a fez? Yeah, fez. As I game fez. This one here is a bit of a wild hat. But, look, for the most part, it does the job. Now, what we can do here, we can obviously save these images and mess around with them. But we can start to modify these prompts. One of the things that I've found is that you really do need to tweak the prompts a lot if you want it to be exactly how you want it to look. So let's say we wanted an oil painting here, but we don't want the dog to be on this weird generic blurry colored background. So we might modify this to say a corgi sitting outside wearing a top hat as an oil painting. And then we would run this prompt again. Wait another 15 seconds and see what it spits out. And I think, look, overall, if I'm going to be honest about where Stable Diffusion is today, it's really a sort of tweak it, play around with it, see where you end up type setup. And sometimes the results are good, and sometimes the results are less than good. So for example, we just changed the prompt to add sitting outside. We now have a very demonic looking corgi, notably not wearing a top hat, maybe outside. It's hard to tell. We have one who, you could ambiguously say it's outside, who is wearing a top hat and has now been given a bow tie. And lastly, we have a picture of a corgi with a top hat and a frame around it. Not really what we wanted with this, so let's see if we can tweak this a little bit more. Let's try something simple, like putting some commas in. Maybe that'll make a difference. Who knows? We will start to play with some of the parameters too, but I want to make some points here about this prompt and this whole, the term that has been proposed here is prompt engineering, which is tweaking these prompts, making modifications to them so that they meet your needs. And I think if anybody is sitting there as a designer thinking, oh boy, look at the quality of these images, it's going to take my job, then maybe worry a little less, because this is very finicky to get right. But lo and behold, the first picture of an oil painting of a corgi with a top hat on that does look like it's sitting outside. Oh boy, this is wild. It is a corgi maybe sitting down, but you can see it has 6 legs, 4 on the ground and 2 coming out of this jacket that it's now wearing. I suppose it associates jackets with with top hats in more scenarios. So that's worrying. And another one which seems to have put the picture in a different setting and is also a little bit demonic. So, all right, that is good. Let's change to something a little bit more simple with a little fewer requirements. And pick something like this. So, landscape photo of mountains and a lake. My goal here is to hopefully get something that looks, vaguely possible, so we can start to mess around with some of these parameters and see how that changes how this image looks, and we can talk about what some of these parameters might mean as we go through and change them. So we've got a few images here. One nice in the daytime. What is very cool about this, although it is a bit broken, is that it's attempted to do reflections in the water, which I think is quite cool. So some of this mountain area has been reflected somewhat well into the water area. But you can see here that this reflection is a little bit more broken, although again, not too bad. And yeah, we got another one here. Again, the reflections, which is quite cool. This is quite a moody photo. I like this one. I'll tell you what, low effort Instagram is probably screwed thanks to Stable Diffusion. I mean, there are Instagram photographers who take photos like this all the time, and the non-discerning viewer, I think, could easily be tricked by moody landscape photo Stable Diffusion. And then last but not least, we have this one, which is an interesting blend of colors. It's a little bit funny. It feels a bit discontinuous there in that, we have this sort of blue tone in the background and then a lighter tone here. The water here is a bit fuzzier. But anyway, the point here was to have a look at how these parameters change. So number one, we've got the size of the image. We'll play with that last because it warrants some interesting discussion, but we've got classify free guidance, which is how much the AI model is being forced to try and cohere with the prompt. So the lower this number, the more it can make its own, for lack of a better word, its own choices. And the higher this number, the more you're going to get what your prompt is, but it can constrain some of the creative freedoms and generate some odd images. These are just batch size. We won't worry about this. Aspect ratio, we'll just stick to square for now. It keeps things easier. And then we have sampling steps over here. So how many steps it does between its original setup, which is basically just noise, and the end. And then we have these sampling methods, which we will go through. So I think that a good place to start is probably the sampling steps, because that gives you a good idea of what exactly this is doing. It also means if we start with lower numbers, it's going to go a lot faster, because as you can see, excuse me, in the terminal, each image has 50 steps, and that's why it takes 4 or 5 seconds. Anyway, let's crank this right down to, let's start with 1. Let's just go crazy and start with 1 step so you can see what the difference is here. And this should, as you can see, be much, much faster. But as you can imagine, the images are kind of crap. So the way that Stable Diffusion works, and all of these diffusion models work, is that they take effectively noise, and they try and shift the noise or sample the noise and move the noise around to create an image that meets the requirements. So in this case, the prompt and some of the other things like the classify free guidance, which gives it a little bit of a varied score. The more steps that you do, the more it's going to adjust that noise, the more it's going to form an image. So you can see here, with just 1 step, it's pretty much nothing. There is some structure here, don't get me wrong. So you can see it hasn't done 0 steps. This isn't the actual true noise. You can see that there is some shape, there is a little bit of color. And if you said, maybe this one looks a bit crap, but these two, if you said, look, these are actually just really blurry, poorly taken photos of landscapes, I mean, maybe you'd believe it. We'll dial this up now. We won't go to 2, 3, 4, 5. You can do that in your own time, but we'll go to 5 and we'll see what a difference it makes going from 1 to 5. What you should see here is that it starts to take a little bit longer, but it's still quite quick. And you can see that the images here very quickly start to have the broad structure of something you might possibly say is, we've said a landscape photo of mountains and a lake. Now, does this at this point look like a photo? No. It takes a lot of detail, characteristics of photos that they are realistic because they're meant to be part of the real world. But you can definitely see a lot of the structure being formed here. You can still see a lot of noise around some of the things like the image, the mountains here. And that is because really this model is all about shifting noise and reducing noise over time with more steps. And it hasn't yet been able to do that. Now let's do it again with, let's say, 20 steps. So we're making a little bit of a jump each time, but you should start to see a pattern here as it starts to get more and more steps under its belt. So here you can see a couple more lakeside areas. You're starting to see a little bit more detail, a little bit more structure around the trees. especially some of these larger artifacts here. What you will notice, and perhaps have already noticed, and it's a little bit to do with the setup. We could fix this to be, a certain seed every time, but these images are not continuations of their previous setup. We will fix a seed for some of these other parameters, but the point here still stands. So we got 20. We're starting to see a little bit more detail, and these are definitely starting to see to look like images of a mountain near a lake. And we're starting to see some of these behaviors like reflection that we noticed before that weren't as present in previous setups, which I think is quite cool. All right, so we started with 50, so let's go beyond. Let's take 80 here as an example, or thereabouts, and we'll generate that image again. Now this is going to start to take a little bit longer because every sample does take a little bit of time. And you can see here it's sort of gone from basically 0 seconds or per step, or per image I should say, to 0 to 1. Before it was about 4, and now we're looking at about 7 seconds. So it's doing about 10 steps per second generating these images. So you can see here, this is at 80 steps. It started to, I suppose there is going to be a sweet spot here. What I would say is this has started to get beyond the point of actual photorealism in a lot of cases. This one's not too bad, but it's starting to get a little weird. There are just some things in this image that are a little off-putting. It just doesn't quite look natural anymore. I can't quite put my finger on it. It does seem to like this whole snow flow around a bulge. You can see that's in that image and also present here in a number of different images. And that's likely due to the training set. It probably had a lot of images of mountains that looked exactly like this. Now let's go up again. We'll double it. We'll go to 160 and we'll generate these images. And then after this, we'll go all the way to the max. And then we will start to play with some of the other parameters, because obviously the longer we spend here, the longer this whole setup is going to take. But hopefully this is giving you a bit of a feel of how this model is working under the hood. So it takes that noise, that randomness, and starts to shape that noise and move that noise into something that is coherent and conforms to the prompt that we give it. The more times it's allowed to do that, the more it can tweak and adjust the image. To a certain point, that's going to help us get more high-resolution detail, more interesting and, I suppose, more complex behaviors like reflection. But after a certain point, it's going to start over-optimizing. So it's going to tweak little things to help the classifier get a higher score to say, yes, this is indeed a landscape photo of mountains and a lake, but we may lose some things on the way through. These ones actually look not too bad. There's some strangeness here, I think, with the way this cloud and this mountain are interacting, but that's not too bad a photo. We're still getting that interesting reflection behavior. This one looks a bit artsy. It looks like it has an Instagram filter on it, but again, not too bad. You can see some funny artifacts here at the boundary between what appears to be maybe some trees and the lake. In which it's half-formed and disconnected some objects, and that's a common thing you're going to see with stable diffusion. Here, this is another nice one, nice clear sky, some pretty good reflection happening here, which I think is quite cool. So we'll do one last run with this, and we will take it up to the maximum number of steps that you can get here, and we'll see what it puts out, and that'll give us the full gamut of how sampling steps affects the image generation here. We'll then start to have a look at these different sampling methods. Now, I don't know the intricate details of all of these, but it's worth talking about how the images differ and what sampling methods even mean in this context. Because we can see, and it may not happen for this prompt, we may need to play with the prompt a little bit, but it can have quite a big effect on the style, I'd say, of the image that comes out. And there's been some interesting work done on this, which is sort of creating a matrix of the same prompt with the same seed with many different samplers and different configurations and assessing how the images change under that setup. But we'll get to that in good time. So you can see here at the maximum settings, it's about 25 seconds, as I said. My computer, which is over there in my room, is starting to make a little bit of noise with these extra steps. I suppose the fans are kicking in on the GPU, but we'll switch back to 50 steps soon, and that'll allow us to go a little faster. So here it is with maximum steps. We have 250 steps on the prompt, a landscape photo of mountains and a lake. And you can see probably at this point, there's not a huge amount of difference between the 150 and the 160, I should say, and the 250 that we did right now. Some of these do look very high quality. I mean, I think this would be a passable, again, Instagram photo of some mountains near a lake. This one is very weird. So I think this one, it started to break down a little bit, as you can see in the reflections. So what's being reflected from here is generally pretty good to a point, but there is some reflection which looks like it may be reflecting the foreground in quite an unnatural way, disrupting that realism in the photo. Anyway, so that's what happens as we move through the steps. Let's drill this back down to 50 samples. We'll put a seed in here. We'll pick the old classic 42, and we'll generate some images with the KLMS sampler, and we'll use this as the baseline for what we're going to look at next. So we're going to go through the different sampling methods with the same seed, which should hopefully keep the images looking reasonably similar, if my understanding of the configuration is correct. And then we'll see how these images change with different samplers. So here are the three that we've got from this prompt. And we'll do this with probably two prompts here. One that's photorealistic and one that's a bit more artistic, to have a look at the difference. So we've got some mountains in the background, some trees up on a hill here, and a small lake in the foreground. We have mountains, lake, that nice reflection behavior, a couple of trees, quite similar, and now a sort of wider angle shot. You can see some of these funny artifacts here again at the transition, but overall not too bad. So that's with the KLMS sampler. We'll now switch to the next one up in the list, which is the KHEUN, Hewn, perhaps, sampler, and generate these same images again and look how they change. It'll be easier for you if you're watching this, especially if you're watching this after the fact, because you can jump back and forth between the images. I'm going to have to play a little bit of a memory game here because I didn't create a setup to save these images and compare them side by side, which would have been smart. But anyway, so the different samplers here is changing the way that, subsequent steps of this sort of noise shifting or this diffusion process happen. It's kind of akin to changing optimization methods, or if you've done a little bit of AI work, changing something like the optimizer at a high level. You should end up with something fairly similar, but you'll see slightly different results overall. Now you can see here, this one, to my eye at least, didn't make a huge amount of difference between these two samplers. The images do look fairly similar, which is great because we have a fixed seed, and that's what we wanted to happen. I feel like the sky boundary, this sort of sky mountain boundary here is a little bit different on this compared to the previous one. We still see some of those artifacts in there. Again, the way it's looking at the sky, it feels a little bit more washed out than the previous set. But, overall, again, some nice artistic photos here. The more we work with this prompt, the more I really do feel that Instagram nature photography might be a little screwed. All right, now we got K Euler, which is a different sampler again, and we will generate these same three images. What I might even do is, nah, forget it. We'll keep going. All right, so interestingly, if you're having a look here and keeping an eye on the terminal, you'll notice that the sampler that we just used there was a little bit slower. So there is going to be some difference in the speed at which these sample, and that'll have to do with the complexity of these samplers and how they run internally. Again, not too much difference here. Fairly similar overall, which is fine. I feel like this tree was perhaps a little less prominent in the previous one, but I'll leave you to have a flick between them. I may do a write-up after this and do some comparison of these. We've got K Euler A, which I imagine is not too different from K Euler, but we shall see. For completeness, we will go through each one of these as we tick along. All right, so we're going a little faster again here. Not too much difference between those two. All right. Now that's interesting. As you can see, there's some drastic differences here between this batch and the last batch. We had a fixed seed, so you wouldn't expect too much difference if these samplers work the same, but this is a little bit of an example of how the sampler can affect this, is that the sampler's job is to determine the path from the original noisy state through to a final image. And even with a fixed seed, and the fixed seed really being affecting sort of initialization, initial parameters, where there is some setup in parameters, taking a different sampler and hence a different way to decide how to move the image in order to reach a prompt, it can adjust the final image outcome. Now, some of these probably take a fairly similar path, and that's not making a huge difference, but we are seeing here that there is certainly some difference between these setups. These images look sort of drastically different to the ones before it, which is sort of the first time that we're seeing this. Now, we'll go to KDPM2. I truly should have looked up a lot of these acronyms before we got started, but it doesn't matter. You can look them up. And it's likely just a bunch of words about who discovered them or how the actual sampling process works. So not hugely important in the overall scheme of things. So this one seems to be a little bit of a slower one again. You can see we got about 5 samples a second here rather than the 10 or 11 that we were getting before. So we'll see how this changes it. All right, now we're back to images quite similar to our originals. You can see here we've got our old familiar tree and funny sky mountain boundary. This one again, you can see what I was describing in that previous set is the large tree is actually a collection of trees in this one, which seems to be trees heading up a mountain side, whereas the other one, I suppose, determined that it was a single large tree making up that space. This one here again, I think this sort of land-water boundary looks a little bit nicer in this particular sampler, and the reflections here look more sharp than their actual sort of above-water counterparts in this one compared to some of the others that we've seen. A couple more to go. KDPM2A. So what have we got here? Roughly the same speed as that previous one. It's likely that these, 2 and 2A variants are small modifications on the same process, so you wouldn't expect too much difference here, although that is where we saw quite a large difference before, so who can say? One moment. I am on the mend from some COVID, so I do have a little bit of a raspy voice here, so I apologize. All right, so here's something revealing. This is the A variant of KDPM2. Before we used the A variant of Euler and got images very similar to those that have been generated here. So it's likely that whatever this A variant is referring to sends it down sort of a common but different path to the other samplers in our setup. what I find interesting here is there is some similarity, especially in sort of this boundary shape to the sky, comparing these two setups. But overall, these prompts are quite different. You do see some landmass on this side in a similar way. This one has a bit of a stony beachfront, but look, honestly, it might be reaching to say that they are somehow the same. All right, we got PLMS, which is another quick one. And we'll see what that generates. So look, if you're using this for sort of research purposes or looking to build on top of Stable Diffusion for your own purposes, hopefully this gives you a bit of an understanding of what all these parameters mean. If you're using this to generate art, hopefully you can see that there's a lot of options for playing around with parameters here. Now, PLMS seems to have gone back to our similar one. I feel here the sort of boundary between trees and rocky interface is a little bit cleaner. It looks a little bit more like there is a separation there. Within this one, we're starting to see some funny artifacts. So, the shape of the mountain here is starting to look a little unnatural. You can see this tree here is sort of split at the top, like two trees. And I feel like there's a little bit of blurring in some of the image space here. This one's looking fairly similar, but you can see that what was almost artifacts or high-resolution details earlier has now become sort of strands or very individually defined strands, which I think is an interesting increase in that type of detail. Now, lucky last here, we have DDIM, which I assume stands for Dance Dance Image. I'm kidding, obviously. Hopefully you understand that I'm being sarcastic here. So we got another quick one here in that sort of 4 to 5 second territory of image generation. So fairly similar overall in this image. Similar again here, except you can see that, that funny curvature that was in the mountains here is gone. I'm only just now realizing you can't see my mouse pointer, so hopefully my descriptions are apt. Again, here on the right, you can see it's blended that tree into one ginormous tree, as opposed to a differentiated sort of rock tree boundary. So that is the different samplers. So what we're going to do now is we're going to go back to KLMS. I'll generate these images so we have the baseline again. Because that is the default K-Diffusion sampler, no other reason, not particularly important which one we pick, but that's the one that comes out of the box. So we might as well go with that. Alrighty, so back to multiple trees here. There is a little bit of tree splitting on that main tree in the foreground here. But back to our tried and true. What we're going to have a look at now is this classifier-free guidance scale. So how closely the image should follow the prompt. Once we're done with this, we'll play around with some of the sampling methods with a more artistic, non-photorealistic design, because I think that from what I've seen, when you're looking to achieve photorealism, there's really not too much in terms of changes in style or features that you can express, because photorealism is photorealism. Whereas if we're looking more artistically, there's a lot more directions we can go, because a lot will count to being an artistic interpretation of the same thing. All right, let's go. Okay, goes all the way down to -40. So we're going -40 classifier-free guidance here to have a look at what it spits out, and we'll move throughout and see how that changes. My dog is currently doing his favorite activity, which is digging the carpet. I'm not 100% sure why he does it, but he seems to do it and then lie down in that spot. Hopefully the noise is not too loud, but wow. So here you can see with -40 classifier free guidance, same seed, same prompt, we have some truly odd outputs. We have what looks here to be maybe a very distorted picture of, I don't know, it looked a bit like Michael Jackson, just in the way that it's dressed in the hair. I don't know what's going on there. We have some sort of combination of text, which could be a very odd logo. And we have this creature, which appears to be some sort of alien who perhaps won a prize at the Olympics. I have no idea. That, I mean, truly says to me that going negative probably pushes it away from the prompt, but we'll see as we shift it. All right, so let's go to -20 and have a look at what comes out the other side. Now, you shouldn't expect too much difference in terms of the guidance in relation to the speed of image generation. This is really just going to change how these images look. Alrighty. Okay, still a bit odd. It's still in the negatives, so -20. So what do we have here? We have the bottom half of a person in a suit with what appears to be another person in the background on a red carpet. Nothing to do with trees or landscape photography. We have a product shot of a phone case for some sort of fictional phone. Okay. And this guy, I guess, in a jacket, looks a bit like an oil painting. My guess would be that at this level, we're probably landing in some of the regurgitated training images. But yeah, very strange. All right, let's try a low value, like a -5 on the guidance and generate again. This is truly bizarre. I don't know why you'd ever want to go negative in terms of the guidance, except perhaps for creative pursuits, let's say. It's hard to know. All right. Man, it really loves the red carpet when we talk about photos. All right. Some strangeness again. I mean, I will say many of these do seem to be photos at this point. We have a picture of the inside of a house, perhaps. Weird Airbnb listing. A photo of some doors and some drawers. Possibly some product shots of Craigslist or something else. I don't know where this stuff came from. And some people at the Oscars. I reckon that's it, taking a photo from the Oscars. I mean, looking at the background. 2 people hanging out at the Oscars. Very strange. All right. Let's try now 0. No guidance on the classifier. It cannot possibly be weirder than what we've seen so far. But yeah, I would imagine that if you're putting classifier free guidance scale at negative, that's pushing it away from the prompt. So you're very unlikely to see something that you asked for. Now, at 0, we have maybe a watercolor painting of a building, a very odd looking one. Another internal shot of a room that is very distorted, warped, and weird. A picture which looks like it may have been, just judging by this little draping white area, maybe a wedding photo, given there's a tuxedo and some other things, but truly, who knows? All right, so lesson learned, negative is strange. Let's go to 1. A small, but hopefully useful and prompt generating boundary for us to work with. Okay. seems I am broadcasting in an odd resolution. But anyway, all right, so we've moved back into the positives of the classifier-free guidance scale, and we're starting to see something that looks a little bit like landscapes, albeit a bit odd. So we got some trees, we got our lake, we got our mountain. This one looks a bit more like an oil painting than a photo. We got a nice little house here. And again, we've got it there. It's interesting that some of these seem to have artifacts that come from the seed. So you'll recall that with the higher classifier-free guidance scale, in this first image, we typically had this tree on the right-hand side. In this case, a large tree, but in later images, it was broken down into smaller trees. The second one, I feel like the colors and the overall aesthetic or vibe of this is quite similar. And this one here, you can see along the bottom, some of these fine detailed items, these sticks, you might call them, are pretty similar to what you get at the higher guidance levels. So it's likely that whatever original configuration of noise that comes out of these setups is being carried along the stronger we go for the prompt. All right, so let's head to 4, which is sort of halfway between where we were before. And continue from there. Okay, my video is in a weird resolution. We're just going to have to deal with that. I thought it was funny in OBS, but it was telling me it was fine. Anyway, stronger guidance here. You can see, as I said, first image, tree on the right, a large tree on the right, some further trees. This one, the building in the foreground has sort of disappeared and we're back to our double tree. And this one, you can see the grass there, which actually looks quite nice at this guidance level. Now, the default we had before was 7.5, so we'll skip right past that and double it to 15 and generate these again. Oh, hello to Mitch in the chat. All right. Cool. All right, let's see where these ended up. So our first one with trees on the right has now become a definite tree-rock separation. You can start to see that it's getting back into weird zone once again. This one here, these trees are starting to separate. We're starting to see some of the blurring on the right side. I feel like this is definitely, in all cases, getting to over-optimization territory. Now we'll just go maximum, 30. And have a look where that takes us. You can kind of expect that the harder you push the guidance, the more it's going to start to get weird because it really, really wants to meet its own internal definitions of a landscape photo of mountains and a lake, down to the smallest possible margin of error. And because this is AI, that means a weird numerical optimization as opposed to a true, human level or human voted level of quality. So you can start to see here, as we've pushed this classifier free guidance right up, it's getting a bit more cartoony. It looks a bit less like a photo compared to what it did before. We've still got that tree on the right. That seems to be pretty consistent with the seed. It'll be interesting to see if with different prompts we get similar sort of artifacts carried through. Here again, looks pretty similar, starting to get a bit weird, bit cartoonish, or just sort of hyper-optimized in a weird way. This one here, again, all of our little sticks down the front have disappeared and become sort of an own mini mountain. So yeah, that is the effect of modifying the guidance. Now let's go back to our original default of 7.5, just so you get an A-B comparison back to where we were before. All right, so here we are with our old familiar images. We got the tree mountains here. We got Doubletree here, looking fairly nice. And you can see here we've gone back to having some sticks in the foreground with some rocks. One moment. Oh, hopefully that is not too loud for you. All right. Now, as I said, let's have a look at a more artsy type setup. Something that's not supposed to be photorealistic. So we will say digital art of a unicorn fighting crime in Tokyo. We'll see what this generates. It's meant to be weird, but the goal here is hopefully to be able to tweak the sampling methods again. We'll pick a subset of them this time. We're not going to go through each one and have a look at what comes out the other side. We'll then start to have a look at width. There are some points that I think is worth making in terms of the width and how this image is trained, this network is trained. And then we'll have a look, because we're about halfway through here, at the image-to-image and play around with some of those features. All right, so what do we have? With our prompt of 42, we have this lovely unicorn here in what could be Tokyo. Some, pictorial-looking language in the background. I'm not going to claim that that's Japanese. One, because I don't know Japanese, and two, because this model is not very good with text, but it's something that kind of looks like a unicorn. It's definitely digital art. Here's another one in what appears to be a city. And this one, it's a unicorn with 5 legs and a second horn. What I find interesting in this one is if you look at the bottom right, you'll see a signature on the image. We'll see if there's those in any of the others. No, but that's something I've noticed a lot in some of these, which I think comes from it would come from the training set, where a lot of people will sign their image. One thing that I have found is that a lot of people seem to put trending on ArtStation at the end of their prompts. Now, that is hopefully, obviously, a strong bias as to where a lot of this training data came from. I can't remember if it's ArtStation or somewhere else, but it tends to generate pretty good images because those that trend on ArtStation or wherever it is tend to be pretty good. Well, it's certainly changed the style. So you can see fairly similar sort of concepts. The unicorn in that same city, a bit more moody, a bit more dark colors. This one now is just a unicorn, maybe some nice fire effects, but similar sort of overall style of unicorn. This one here, well, it has 4 legs now, which is positive. I don't know what this thing on its back is. Second horn, who knows? But let's work with this. So this is with KLMS. Let's jump to Euler, then we'll do Euler A, because they were quite different last time. And then we'll have a look at some of those up the top. So DPM, DPMA, and PLMS. Just to give a quick little look at all of the different samplers and what effect they have. All right, so you can see slightly different artistic style here, but really overall quite similar. Yeah, still in that digital art style. Still with the same sort of mood, I suppose, overall. But let's switch to A. Now, if you recall, last time when we switched from Euler to Euler A, we saw a big difference in the overall image. So I would expect something pretty similar here. But I think hopefully throughout this whole thing, you've... okay, here we go. Let's talk through this. The city is gone. So it doesn't look like a crime-fighting unicorn. Has 5 legs. You can see a signature there on the right. Another unicorn, a slightly different signature there on the bottom left. Not in a city. not fighting crime. And here's our third unicorn. Again, a signature on the bottom left. 5 legs seems to be common. And similar sort of style. But you can see there switching from Euler to Euler A made a big difference. We'll switch back to DPM2. Likely go back to pretty similar images to our first ones. And then we'll continue from there. So what I was saying before is that, again, while this is impressive technology, and it's very cool that we've been able to train AI to move from noise into something that is a coherent image, hopefully you've seen that, there's a lot of tweaking that needs to happen here to get something that is high quality. These images, they might pass the bar if they're going to be small or out of the way or not being used too much. But if you were, let's say, setting up an online service to sell stock images, and somebody paid good money for digital art of a unicorn fighting crime in Tokyo, trending on ArtStation, and got this image as a result, I think it's fair to say they would likely be disappointed. It doesn't meet the spec. And there's a lot of back and forth that needs to happen in order to get any of these images to match the specification. We'll make this the last prompt, and then we'll try and tweak this to get this to be a little bit more in line with our prompt, and then we will have a look at size, because that's another important shift. And then we'll move to image and have a play with that. So this is KDPM2A. It's likely to be in that strange set of alternative images, similar to the other A variant. Yep, as you can see, there's pretty good alignment there. It's a unicorn for sure. It's got a signature on the bottom right there. This one, at least, again, is back in a city. Has a similar signature there on the bottom left. And this one looks fairly similar to all the times it has before. And lucky last, we'll go PLMS, because that one's quick. And we'll now play with the prompts. So if you're going to use this practically, what I would say is that you really need to start to familiarize yourself with certain keywords that make a big difference to how... Oh, look at that. How these images change based on those keywords. It appears to have a person on it now, which kind of makes sense and is kind of funny and kind of cool. This one has some sort of protrusion coming out of the left side of its head. And this one's back in the city fighting some crime. Alrighty, so let's try again our very boring technique of putting commas in and seeing if that makes a huge difference. We'll stick with PLMS because, whatever. They're all good enough. They all generate images. This one made sense of that third image, and that's reason enough for me to stick to it for the time being. All right, so we can see with just some commas, and this again sort of gets to my overall point here, is that adding commas in this, sure, it changes the sentence grammatically. I don't know if it cares whether sentences are fully grammatically correct. My goal here was to separate different components of the prompt, but you can see it's become very strange. This one, I would say, is probably a little better in that there is more of a defined city around this picture of the unicorn. This one here looks remarkably different, but captures some of that city element once again. Let's try another comma just here and see if these different things, which is unicorn fighting crime in Tokyo and the style parameter, are better separated with the additional comma. Well, different style again, but overall fairly similar images. This third one is always very bizarre. All right. let's now have a look at width. So the important thing here is that the Stable Diffusion work was primarily trained on 512 by 512 images. So that's its sweet spot. It knows how to generate those. That's where most of the training was done. Now, if you haven't got a lot of RAM on your machine, you can generate smaller images, which you'll see here. On this one, you'll see that they'll be a little bit faster because of less pixels to have to diffuse across. But what I've found in my tests is that often the smaller images start to become a little bit incoherent. So you can see here, there are sort of some unicorn-like features in this image, but it is nothing like the quality that we got at the larger size. And this is another one of those shortcomings, or not the shortcomings per se, but limitations of Stable Diffusion that make me think that the design world is safe for now, is that even such a small change really disrupts what the image looks like. So we'll try it slightly bigger, closer to 512. But one of the important things here is that it must be a multiple of 64, I believe, pixels based on the way that it patches images and breaks them up and works with them. Now, look, that's not a bad thing. It's just a limitation of the image that we need to understand. So you can see here as we got bigger, it started to get a little bit more realistic, or a little bit closer to the prompt, I should say, than the 256 variants. I won't go above 512 because whenever I've tried that, it tends to run out of RAM. And we'll be starting the stream in debug mode, or continuing the stream in debug mode if we end up running out of RAM. All right, so what I might do now, so we'll start to have a look at image to image, which I think is quite cool. To do that, let's get an image to work with and start to make some variants of it using image to image. So I'll start with a picture of a spoodle. I have a spoodle. Do I have a spoodle? Is that the right term? I don't know. Caucus? Yeah, sure. Similar. He doesn't look like any of these. I guess he most looks like this one. But we'll take this image and we'll move it over to image. So I can press this button here. That pops it over here. So we're now looking at image to image mode. And what this does is beyond just, oh, there you go, training on ArtStation. Beyond just taking a prompt as an input, it takes an image as an input as well. And it can make modifications to the image. It can put the image in different contexts. It can do all sorts of stuff. So there's a bunch of settings down here, very similar to those that we had before. We're going to leave them as the default. And we're going to have a look at different ways that this image to image can work. So this is the picture on the left. And we will say, let's say wearing a backpack as a starting point. So let's see if we can get this dog to wear a backpack using image to image. I've had mixed results with this. As you can kind of see, there is a backpack in this image and there's grass, but it's very much lost the original the original dog of this image. So what we'll do here is we'll try and crop around the dog and see if we can make something more useful, because unless that bloke's name is Spoodle, that's not exactly what we wanted. All right, that's a little bit better, and sort of demonstrates what image to image is all about. It takes an image, it makes modifications to it so that the image as a starting point adheres more closely to the prompt. So you can see here, this is a dog of sorts wearing a backpack, which is kind of what we wanted. You can obviously, rather than modifying the content, you can start to do things like change the prompt to change sort of the visual nature of the image. So taking what was a photo, turning it into digital art. Here's one I haven't tried before. Let's see if it works with pixel art. I have a soft spot for pixel art. And we'll see if it looks any good. I mean, not too bad overall, kind of cool. So you can see here, we can change the style of an image. One of the things it's on my to-do list today is to generate a YouTube thumbnail for our previous podcast episode, which was talking about Stable Diffusion by using style transfer within Stable Diffusion. Now let's have a little squiz down here. So some things that it mentions is that it's all very temperamental, I think would be the overall summary here. Is that, the using just a straight image here as a input, while you can sort of move it around and things like that, and paint outside the image, which you'll see here. Let's just say photorealistic in a park. Having a full screen image and then just trying to change the style can be a little bit odd. So this is the point that it was making before, is that, perhaps I need to just do this. Give me 1 second. Learning together is always fun. So what I was hoping to do here, to achieve here, is put this dog in a smaller portion of the image and generate some stuff around it, which you just really did not do what I was hoping. Let's just try. Oh, okay. That didn't work at all. Here we go. Let's mask out the dog. Now, hopefully this will maintain the part of the dog. It is amazing that all of this is free, I will say, even if it is a little temperamental at times. I don't know if I actually have to color this whole thing in, so I'll just do a poor job of it and generate and see what this ends up with. Probably something chaotic. Oh no, not too bad. All right, so you can see here, this sort of achieved what we were hoping for, which was taking the context of the dog and putting it in a new setting, in this case in a park. I'll drop the photorealistic and see if we can get a slightly better result with just that. Okay, let's say in a car. The dog already does appear to be somewhat in a park, so that's probably not the best prompt. Okay, no. Doesn't like that. All right. Good. All right, so that's image to image. As you can see, you can do a lot with it. You can sort of start to go down a weird process of sort of adding things, reusing the image as part of the image to image result. It's just not having a bar of this. So let's try this uncrop mode, and then we will talk for a little bit, and then I think I'll probably call the stream pretty soon, because we've done a whole lot of stuff here and there's a whole lot of content to dig through. So hopefully that gives you a little bit of an understanding of how Stable Diffusion works. This is pretty easy to get up and running if you have a somewhat decent kit of hardware, modern GPU. The main thing is VRAM on that GPU. Normally you need 10 gigs. I think the 3080 has 12. But you can start to play around with it and have a lot of fun, which is the main thing here. I think in terms of AI engineering, what I really love about this is it's been, it is a free tool for you to play around with. It runs on, most beefy modern machines. You can start to engage with this. You can start to understand this in a really good way. So, we've got DALL-E 2, we've got Imogen, we've got a whole bunch of other setups, but what's important here is that this is free and openly available. You do need a Hugging Face account. And there's a little bit of fiddling that goes on to get it. The Hugging Face account is just to get the weights, but it's free. And that is really, really cool. Is this the end of art, the end of designers? No, not by any means. There's still a lot, as you can see, that it struggles to do well. There's still a lot of tweaking and prompting and things that need to happen. But if you were using this to generate some imagery to inspire some ideas, let's say you are writing a book and you want to, write about a castle set out in a forest, and you want some inspiration about what that might look like, maybe to draw your own image, maybe to write about your own image. This is a good way to generate some of that. It'll give you a little idea about what that might look like, and you can play around with that. But it's not going to take away graphic design. Certainly a lot of graphic design in my world as an engineer is mock-ups, user interface design, and things like that, which require a level of sort of fine-grained control and pixel precision that this model just isn't able to generate yet. Will that ever be the case? Perhaps. But really right now it is not at that level. It's a great tool. It's a very interesting piece of engineering. I highly recommend, if you're checking this out, to jump into the code base, have a read about the various bits and pieces that glue together to make this model work. With a little bit of reading on UNets and text embeddings and some of the more modern variants of those types of systems, you can really understand what's happening here under the hood. You can then sort of extrapolate that to how the model would have been trained and start to work with a really deep understanding of how this model works. Now, there are some things in here. There's a watermark generator and not safe for work sort of filter, which are there as a demonstration of how I'm supposed to be ethical and responsible with this type of model, understanding how those work and where they fit into the system, both to understand the bits and pieces, to get a better understanding of the ethics of this setup, but also, if you want to turn the watermark generator off, you can. All this code is available. It's all ready to go. You don't have to buy credits, and you can start playing with this right now. So, very cool application of technology. We're likely to see newer versions of this, newer variants of this, cooler stuff come out. But for now, great piece of kit. Not going to disrupt design, but you'll probably see a lot of this stuff on social media, and a lot of, generic, boring stuff may be replaceable with DALL-E. I'm sure there is already a slew of fake Instagram accounts on, fantasy destinations that pass the bar for a quick scroll past and alike, but are not quite there for the discerning viewer. So hopefully this was interesting. Thank you so much for those that tuned in live and those that are watching after the fact. If you're interested in AI content, both at this level and getting a little deeper and understanding how it might apply to your work, if you're an AI engineer or work with AI as a day-to-day technology, please subscribe. We making more and more content. Check out our weekly podcast. But other than that, friends, viewers, everybody else, thank you so much, and I'll catch you next time.